Hello, AP Physics 1 students. Okay, so you were asked to read through the entire circuits activity so you get a sense of what's going to happen here. The front page is really, really important, except not for today. When eventually, I come back and you actually get your hands on the equipment, you really have to know the safety issues. We're using lab volt. I'm going to go over the actual physical meters, how they're connected, and how to read them. And you will be able to build actual circuits doing so. But for right now, you can sort of skip over that, and you can look right ahead at the first circuit diagram, which is the single resistor. And then you're also going to access the link on the Google Classroom page there to get to the circuit construction kit, the PHY simulation. When you get there, you're presented with two choices. You're going to click on the lab setting. You're going to get a screen that looks sort of like this. Now, there's all sorts of really cool things you can do with this, and you will have a chance to do that. But please, 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 please do the stuff I'm asking you to do first, and then if you happen to finish and you want to play around with it, please, you're more than welcome to. But I'm really concerned about us falling behind. That's why I'm having you do all this stuff when I'm not there. So you have to get done the stuff I asked you to do, and then if you don't finish that, you got to do it at home, because I'm really expecting you to get those things done, meet those goals, so we don't fall behind. So when you have this, sort of playing field here, there's all sorts of options to choose from. First of all, I'm going to click on this, which is going to make everything look like a schematic. You certainly could do it in terms of lifelike pictures, but let's make the schematic symbols, and here are all the different things you can choose from. And when you click on here, you can scroll down the menu. You're going to see a lot of very interesting things, some things that you may be tempted to play with. Once again, I ask, don't do that yet, please. Just do what you're supposed to do, and then afterwards, if you have time or at home if you want to play with those things, please feel free to. There's a lot of fun things to do, but there's also some very important things that I need you to learn. I want you to click on conventional current, because remember we're going to track protons, not electrons, so conventional current. You want to click this for values. This way you will be able to see the values of the voltages of the battery and the resistances of the resistors. You'll also be able to change those things. We also have the option here, which I really want you to do, of increasing the wire resistivity. Lots of times when we do this, we move the slider all the way down to tiny, so that we pretend the wires are perfect conductors. But that's not the real world. And that's really what I was always worried about here with giving you this assignment and not having you do the actual circuits, is that you're going to get data that's too perfect. So to combat that, you're going to move the slider up just a little bit, so that you will have some resistance in the wires. You're not going to get perfect data, and then they'll force you to really dig in and try to find the patterns there. And then if you want to go back and you want to do it without resistance in the wires, and so you can see the perfect data, that's fine. But as you take your data, do move this up a little bit. Not a lot, just a little bit, so we'll get some imperfect data. That's good stuff. Okay, so when your circuits activity, you're looking at the first circuit diagram, and your job is just to select the materials here and build that circuit. Make it look pretty much exactly like it is on the page. Your ammeters are over here. The voltmeters over here. Remember, the voltmeter's not really in the circuit, so don't bother with that yet. I would choose this ammeter here. That's the one that actually goes in the circuit. This is what it's going to look like, right? We need the battery there, an ammeter, a single 10 ohm resistor, and then a second ammeter. So really, your goal is to try to make it look as much like this as possible. The voltmeter is not really in the circuit, right? If a voltmeter were to be in the circuit, it would be parallel to whatever you're reading. So for example, parallel to the battery, to read the battery voltage. So that's why I'm drawing these sort of dashed lines here. It's not really part of the circuit. It's not part of the circuit diagram, but this is how the connections will be made to measure from one side of the battery across to the other when you need to do that. If you want to measure the voltage across the resistor, that will be in this case delta VR. You would put it here. Now you only need 1 voltmeter. In fact, you only allow 1 voltmeter when you access the circuit builder, and so you just move the wires over from one side of the resistor across to the other. Now it's going to measure delta VR, the voltage across that resistor. And you don't have to change anything. It's not going to change anything about your circuit. And in the real world, when we actually build the circuits, you'll unplug the voltmeter from the battery, you'll plug it in across the resistor, and then you plug it back to the battery. It's not going to change anything. When you start selecting your materials here and bring them onto the playing field, for example, you bring a battery on here, and you click on it, well, then you're going to see the voltage of the battery, and you'll see this slider down here. And now is where you get to change the voltage, and you'll see, having read the activity, you're going to start at 5 volts. And so you just move the slider down to 5 volts across the battery, and you start pulling the other things onto the field and start making connections, putting other wires in between, putting the ammeters where they belong. When you click on the resistor, you'll get a similar looking slider. You'll be able to change the resistance of it, and the first resistor is a 10 ohm resistor, so make it a 10 ohm resistor. And from there on out, you're just going to take your data. And then just follow the instructions. Do exactly what it tells you to do. You can change the battery voltage to different values here, to take different data, fill in what I1 reads, fill in what I2 reads, and then comes the really important part, the part that you're going to want to skip through, but I ask that you don't, since I'm not there to supervise. Then you have to do the analysis section. Okay, so there's the analysis section down here where you're going to analyze your data looking for patterns. Don't move on to the next circuit until you do this step of analyzing your data. So you're looking, at a row across, what patterns do you see? As you go down the rows, what patterns do you see? What sort of connections do you see among the quantities there? Now here, I know that some of you will have some experience with this. Some of you have already built circuits, some of you studied this before, which is fantastic. And as you're discussing these things, you're going to want to just give the answers. I ask that you don't do that, right? When you're working with people, when you're talking it out, let other students look for the patterns and see if they can figure it out, because this is a learning experience. This is a discovery activity. And if you just give them the answers, well, then they're not going to learn, right? And so certainly, if you're waiting for some other students you're talking with to try to figure out the patterns and they're really getting stuck, maybe give them a hint or two, say, oh, look at this, and did you notice that? And then that'll help them along. But just giving them the answers really doesn't help. This is a learning process. And then when we actually get the equipment in our hands, everyone's going to learn how to build the circuits and see the patterns from that as well. Before we move on from the single resistor, please make sure you do the next step where it asks you to swap. I'm thinking ahead to the series resistors. Now you're going to build a series circuit there with the 5 and the 10 ohm resistors. Again, do the same deal. Start at 5 volts across the battery and go on down from there to the analysis section, looking for patterns. And then there's that one extra step, making sure before you go on from single into parallel that you do swap the placement of the 5 and 10 ohm resistors. You want to see if anything changes, what changes. Write down some notes about that in the analysis section as well. Your goal is to get through the single resistor, the series resistors, and the parallel resistors. It really isn't a lot. If we were doing it live and in person with the actual equipment, this would take quite a while. You're absolutely able to get done with that material, and we should then be ahead a little bit in that sense, although we have to backtrack and look for the patterns and other things as well. But that is the goal, to get through that. Don't go on in the activity, because that involves using the light bulbs. And for those, we definitely want you to have actual light bulbs in your hand and actually build the circuits, and we'll be doing that in class. Okay. So again, your goal is to get through the single resistor, the series resistor, and the parallel resistor circuits. Get all the data, do the analysis for them, make sure you swap the position of the 5 and 10 ohm resistors, see what happens. And then if you get finished early, then you can play around with the circuit builder and do all the weird things that I know you're going to do, and we'll talk about that as well when I get back.